So in this video, we'll be going over phase changes and enthalpy changes. So let's start with the basic. So these are the processes from different phases. So you need to know all of these, and you need to know both of the names. Let's say from solid to liquid, it's called melting or fusion. So in the exam, it could be any of these, and the third one, which is the important one, which is this one, is from when we're going from solid to gas. It is directly, it's called sublimation, and the opposite is called deposition. And let's go down then. So these are the formulas for calculating change of states for enthalpy values. So when you are given the units of kg per mole, you use Q, which is the energy, it equals to moles, number of moles, which is N, times d delta H. And when you're given kg slash divided by grams, then you use the grams instead of moles. So now let's see an example, and this will be more clear. So here it says that to calculate the energy required to melt 16.4 grams, which is very important, so you have to check the unit here, of ice, which is water, and we have the delta H of fusion, which is in moles, so kg slash moles. So first thing we need to do is we need to convert this grams, 16.4 grams of ice, into moles. So let's do that. So to get the molar mass of ice, which is H2O, H is going to be 2 plus 16, which is pretty simple stuff from periodic table. And the formula for calculating the number of moles is mass over molar mass. And that's what I did here. And you get the answer of 0.910 mole. So now we can use this first formula, as we have the number of moles now. So all we have to do is just times this 0.91 times the delta H, which is 6.01 kilojoules per mole, and we get the final answer of 5.47 kilojoules. So this is another type of question which you could face. So here we have we need to calculate the energy required to change 33 grams of water from 67 Celsius to 134 Celsius at 1 atm. So the two formulas we're going to use here is Q is equal to mc delta T, and the other one is the one we just used, which is m delta H, or N delta H, whatever the units are in the question. So now let's start doing it then. And here we need to find the C, which is the specific heat value, and this will be given in the exam to you. So let's go and see that. So in our question, our temperature was 33 Celsius. So this means that the water is in the state of liquid. So here we have to use 4.184, which is this one. And let's go back now. So now let's start writing it. So first step is from 67 Celsius to 100 Celsius, and then there will be a change of state energy. We need to calculate that, and then from 100 Celsius to 134 Celsius. So let's do 33 times. So we did times the delta H, which is final is 100 minus 67, and here we get the answer of 4,556. And now we need to find the change of state, because we'll be going from solid to gas now. So we need to go and find the value of that. So here we go and see the table value for H of fusion, and it is 2257. We just times it by the grams, and we get the answer of. So now the last thing we need to calculate is the energy from 100 Celsius to 134 Celsius. So to do that, we have to use the first formula again, which is just 33 times delta C of gas, which we'll go and check again, which is 2 from the table, and then times delta T, which is gonna be 134, which is the final temperature, minus 100. That was our initial one, and here we get the answer of 2244. And now we just add all of these, all three of values, and we'll get the final answer. So let's do that. And this is the final answer, and the units is joules. So now let's see another example, and this one you could try doing it yourself and getting the answer. So let's start. So first of all, we have to use MC delta T. So it will be 87 times C for solid, because negative 24, it is going to be ice, which is solid. So let's go and check that. And for ice, the specific heat value is 2.087, and delta T will be final, will be 0 minus 24. So this just becomes 24 if I write it again, because minus is 4, I mean positive, and then plus, since we are changing from solid to liquid, we will need a change of state here. So we have to do 87. So the formula was Q is equal to N delta H, or it was grams, I mean M, the lowercase m for grams, the unit, delta H. So here I'm just using that formula without writing it. So it will be 87 times, and this value 87 times, yeah, this value is the fusion value, which is, we have to find it per gram, 3.6 plus now. So now you're going from 0 to 100. So again you have to use the first formula, 87 times the specific value for liquid now, which is 4.184 times delta T, which is going to be 100 minus 0, which is 100. And now again we're changing state from liquid to solid now, so it will be plus 87 times this enthalpy of evaporation, which is per gram is 2257. And now the last thing which we need to do is calculating it from 100 to 143, which is going to be 87 times the value of specific heat of gaseous H2O, which is 2, times 143 minus 100, which is 43, and now you will get the final answer of 274 kilojoules of this.